Hello, my viewers. My name is still remaining Pinyon with Sunday, and I welcome you all to my YouTube channel on PU Formal Academy. The Academy is all about the experience that work. And in my presentation, looking at the series of my presentations from lesson 1 to 11, lesson 17, okay, you will see a lot that can be of advantage to increase your knowledge and understanding in the production of flexible polyethylene foam, whether you are using continuous process, semi-continuous process, and a batch process. Though I do not know where you are watching me from, in Nigeria, the batch process is what we call box foam. The continuous process is what we call a conveyor. That is a common name used here in Nigeria. Now, this is lesson 18. In lesson 18, I will be looking at TDI Index. TDI Index. Now, what is TDI Index? TDI Index means a way by which a process engineer, the foaming engineer, trying to vary the hardness of the foam. Because foam, when it is produced by a TDI of 100, the foam will be soft. So for you to increase the hardness of the foam, the compression load, the friction of the foam, you have to go above a certain number. And by increment of this extra you are adding to that 100 is known as index of your foam. For example, this is what I'm trying to say. It is of 3 area. 100 means exact. Less than 100 means not enough. Greater than 100 means extra. That's what I'm trying to say. That is to say, 100 is here, 95 is here, 102 is here. So looking at this value, okay, there's something you are going to notice. This 100 take part, in the reaction of production of flexible polyethylene foam, we have urethane formation and we have urea formation. The urea here is mean TDI, okay, plus amine catalyst form unstable acid that decompose, that is carbamic acid that decompose the form CO2 that will blow the foam. Now the urethane is what constitutes the Jana molecule. So I did say that TDI consumption, okay, are consumed in two ways. The amount that will react with water and the amount that will react with the polyol. That's how TDI is being consumed during foaming process. Now, looking at this, it is always good to carry out formulation in parts per 100. Part per 100 is industrial convention, acceptable value that will enable the foaming engineer to accurately scale up the polyol. Okay, that all parameters are based on this amount of polyol, which is in 100. So same thing is applicable to that of TDI. Now the amount that react with water, polyol, equal to hydroxyl value of polyol that is clearly stated in the data sheet times 0.155. The amount that react with water is the part by 100 of water times 9.67. Are we all together? So if this is X and this is Y, you add them together, you have XY. This XY will give you an index equivalent to 100. And this is what we are talking about. Okay, that is exact. In this case, you are not adding anything. It does not list. Okay, but when you add extra by 2, that means you are adding 2%. That is what it means. So the secondary reaction where you have the formation of allophanate, that is the urethane based linkage that is going to form, that also help in the constitution of the strength of the polymer network during the curing process. That one require excess or extra TDI that equivalent to 5 to that of 25%, depending on your process condition. That is to say, if it is taking 5% to 25%, it means that 100 to 5% is 105. 100 to 10% is 110. Then 100 to 15%, 115. Then 100 to 20% is 20, up to what? 125. You understand? So this is how TDI work. Now, in a formulation, you do not choose TDI to be used in that formulation if you do not choose water, because since formulation is impaired by 100, the water is already there waiting for you, that you are going to use and multiply by this equivalent weight derivative from that of water and that of TDI. This is that of polyol. You understand? So in this case, what is simple means that the TDI formula can easily give you this, can easily give you amount of TDI used all over theoretical amount of TDI required in that formulation times 100 over 1. So the theoretical is that it is consumed in 2 ways, from the OH group, which is your polyol, and from water, that will be in a ppH of water times 9.67. Now this one is hydroxyl value of water. Let's assume the hydroxyl value of polyol is 40 times 0.155. Okay, so when you multiply by this, multiply by them, add them together, what is given you is equivalent to 100. But if you choose this 100, your foam may be soft. So for you to increase the hardness is where you are bringing in the index, and the global safety range for TDI index is from 100 to 118, but one can still move to 125 depending on your process condition. But I'm advising you, you can play along within this range. Okay, within this range. Now, as you are increasing this value, as you are increasing this value, okay, if it is low density, you need to take into consideration of 11, let's say 115 to 118. This is for low density, for example, low density. But for higher density, you can take from 114 down to 105. This is for higher density. Okay. So in this case, your formulation is safe. But if you think you still want to increase this, in some company they incorporate fire retardant for high index foam so that the foam will not undergo self ignition. You understand? So this is how TDI works in foaming, and it's very, very good for you when designing a formulation to know at which index you are operating. It's just a guiding range to make your formulation safe so that the foam will not undergo self ignition. Now one may ask, how do I choose it? You want to make a foam density of 17, and the expected water in that formulation is 5. It's already in part. Bring this 5, then fix it there, multiply. So you get a value. So this is a value that's equivalent to that TDI that will consume the water. Then the hydroxyl value. This hydroxyl value varies depend on the manufacturer polyol or production. So it could be 40, it could be 39, it could be 45. So every PU foam chemist must always lay emphasis to some of the information that are stated in the safety data sheet so that it will guide them when designing a PU foam or formulation. Is it not interesting? So you continue to like my page, share my video on your notification bell so that whenever I load a new video, you'll be notified. Thank you. Bye bye.